Here's the AC generator we looked at in class. So here's our permanent magnet. So this, say, is the North Pole, and here's the South Pole. So our electric flux density lines will run from north to south here. This is our coil, which we can rotate. So this coil rotating in this fixed magnetic field will result in a changing magnetic flux inside the coil, which will produce our AC voltage. Now, since the coil is rotating, we need slip rings to connect to it. So this part of the coil is going to ride along the inside of this slip ring, and this part of the coil here is going to ride along the inside of this slip ring, so we can tap our AC voltage at these two connections. Now, alternatively, we could hold the coil fixed and rotate the magnet. It would be exactly the same thing, except since the coil is not rotating, we would not need slip rings to make the connections. And that's what I'm going to do in the simple AC generator we are now going to construct. I took a plastic bottle and cut the ends off to form this plastic tube, and I have some 32 gauge magnet wire here, and I'm going to take the magnet wire and wind it about 500 times around this plastic tube. I have wound the magnet wire around the plastic tube now, 250 windings on the left side, 250 windings on the right side. I've also drilled a small hole on each side of the plastic tube between the coils, and I'm going to insert this round piece of wood through the tube. And so I can twirl the piece of wood, and what I'm going to do is attach a magnet to the piece of wood so that when it twirls, the magnet is spinning inside the coil, so you have a changing magnetic field inside the coils. The magnets I am going to use are these two disc magnets. So I have these two rather strong disc magnets, and what I'm going to do is put them together with the pencil in between. So I'll put a little bit of something in here to be a spacer, and the magnets will just hold in position due to the magnetic force. So with a couple wooden spacers, I can position them on the wood rod like this, so I can twirl it and twirl the magnets. I have the magnets positioned inside the coil such that I can spin the magnets. I've attached a light emitting diode to the two ends of the wire. So when I spin the magnet inside the coil, the changing magnetic field will generate an AC voltage at the ends of the wire. And when the voltage is positive, the diode will turn on, and when it is negative, the diode will turn off. So we'll see the diode turn on and off with the frequency of rotation of the magnets inside the coil. I've attached a drill so I can more controllably turn the magnets. So I'll slowly turn up the rotation frequency, and you'll see that the light emitting diode will go on and off with the frequency of the drill. And in addition, the faster the rotation, the greater the change in the magnetic flux in the coils, and so the more induced current and the brighter the LED will be.